Welcome to Chapter 6. In this video, we introduce binomial random variables and learn how to calculate binomial probabilities. Before we get to the binomial, we need to understand the Bernoulli trial. A Bernoulli trial is an experiment with exactly two possible outcomes, success or failure. Think of flipping a coin, treating a patient, or running a diagnostic test. Each has only two outcomes, and the probability stays the same each time. A binomial random variable counts the number of successes in n independent Bernoulli trials, where each trial has the same probability p of success. We write x tilde lowercase b of n, p for example, if we treat 4 patients, each with a 75% chance of successful treatment, the number of successes follows b of 4, 0.75. Central to the binomial formula is the binomial coefficient, also called the choose function. N choose x equals n factorial over x factorial times n minus x factorial. A factorial means multiplying a number by every positive integer below it. For example, 4 factorial is 4 times 3 times 2 times 1, which equals 24. By convention, 0 factorial and 1 factorial both equal 1. The choose function tells us the number of ways to pick x items from n, for instance. 4 choose 2 equals 6, meaning there are 6 ways to choose 2 items out of 4. Here is the complete binomial probability formula. The probability that x equals x is n choose x times p to the x times q to the n minus x. The first part counts the number of ways to arrange x successes among n trials. The second is the probability of getting exactly x successes, and the third is the probability of the remaining failures. Remember, q is simply 1 minus p. Let's see a concrete calculation of the binomial coefficient. How much is 4 choose 2? We write out the formula, 4 factorial over 2 factorial times 2 factorial. Expanding the factorials gives 24 divided by 2 times 2, which is 24 over 4, equaling 6. This means there are 6 distinct ways to choose 2 items from a set of 4. Let's work through an example. We have 4 patients, each with a 75% chance of successful treatment. What is the probability that none of them are successfully treated? We plug into the formula. 4 choose 0 times 0.75 to the 0 times 0.25 to the 4 choose 0 is 1, 0.75 to the 0 is 1, and 0.25 to the 4th power is 0.0039. So the probability of 0 successes is just 0.0039, less than 0.5%. Very unlikely if the treatment truly has a 75% success rate. Let's recap. A Bernoulli trial has 2 outcomes, success or failure. A binomial random variable counts the successes in n independent trials. The probability formula uses the binomial coefficient to count arrangements, then multiplies by the probability of each specific outcome pattern.